Hello students! Welcome to Grade 10 Science Lesson. I am Ma'am Girly Manalansan, your science teacher. Today we will be discussing Boyle's Law and Charles' Law. For our most essential learning competencies, investigate the relationship between volume and pressure at constant temperature of a gas, volume and temperature at constant pressure of a gas, and explains these relationships using the kinetic molecular theory. Let's start with the properties of gases. Learners, gumawa ako ng separate na video regarding these properties as well as the commonly used units for volume, pressure, and temperature. Meron din ako na video regarding the conversion of those properties that can be measured. Preparation ito para sa ating lesson for today. And with that, let us just recall the properties of gases. First is mass. It is amount of gas present in a container, represented by letter N. Next is a volume. Amount of space filled by gases and represented by letter V. The third one is pressure. Force exerted by the molecules of gas per unit area, represented by letter P. And finally, for the properties of gases that can be measured is the temperature. It measures the degree of hotness and coldness of gases, and definitely represented by letter T. Robert Boyle, 1627 to 1691. An Irish scientist discovered the inverse relationship between volume and pressure. Boyle used J-tube on his experiment to prove his law. He experimented with pouring mercury into a J-shaped glass tube. Nagsalin si Boyle ng mercury sa open-side glass tube. Makikita na nag-increase yung height ng mercury sa open-side glass tube, and the volume of the clogged side was reduced. Robert Boyle calculated the mercury pressure from the height difference, and Boyle measured the reduced volume of the clogged glass tube. Boyle's law states that the volume of a fixed amount of gas is inversely proportional to its pressure at constant temperature. Dalawang properties ng gases ang involved dito sa Boyle's law. Those are volume as well as the pressure. And it says here that it is inversely proportional. It means that the two quantities behave opposite in nature. Kapag ang isang quantity ay mataas, ang isang quantity ay mababa. Now, this is known as the pressure-volume graph or tinatawag na PV curve. As observed from the graph, the pressure decreases when the volume increases or vice versa. Tandaan, ang dalawang properties of gases in Boyle's law, volume and pressure. Kapag ang volume ay mababa, ang pressure ay mataas. At pag ang volume ay mataas, definitely ang pressure ay mababa. At yan ang Boyle's law. Learners, proceed tayo sa Boyle's law equation. Boyle's law is expressed in this equation. V sub 1 times P sub 1 is equal to V sub 2 times P sub 2, where V sub 1 refers to initial volume, P sub 1 refers to initial pressure, V sub 2 is tantamount to final volume, and P sub 2 refers to final pressure. Huwag kayong malilito, learners. Every time na makakita kayo na subscript na 1, ibig sabihin, it refers to the initial condition of the properties of gases. And then pag nakakita naman kayo ng subscript na 2, that signifies the final condition of the properties of gases. At yan ang Boyle's law equation. Let us have sample problem. A sample of oxygen gas has a volume of 12 liters and a pressure of 1 atmosphere. What is the new pressure if the volume is decreased to 4 liters? Every time, learners, na makaka-encounter kayo ng ganitong problem, huwag kayong panghinaan ng loob. Always remember that problems are made to be solved. Solution. Step 1. Write all the given. May mga hint naman dito sa word problem natin, kaya madali natin ma-identify. Ang ating initial volume ay 12 liters. And initial volume is 12 liters. Ang ating initial pressure is 1 atmosphere. Then, ang tanong dito, what is the new pressure? May hint ka na agad. Ilagay mo na si question mark sa final pressure. And then, if the volume is decreased to 4 liters, ang ating final volume ay 4 liters. Napakasimple. Kompleto na ang iyong given. Next step. Write the formula. Initial volume times initial pressure is equal to final volume times final pressure. Ang unknown natin ay ang final pressure. Kailangan natin itong i-derive. Simple lang ang pag-derive, learners. Copy the formula, and then, since ang final pressure ang nawawala or ang unknown natin, dito tayo muna sa side na ito mag-focus. Ang goal natin dito is matira si final pressure. We want to eliminate final volume. Bring down final volume. Kung ano ang ginawa mo dito sa side na to, same with the other side. And then, it is now time for us to cancel final volume. Ngayon, meron ka ng derived formula which is final pressure is tantamount to initial volume times initial pressure over final volume. Step 3 tayo. Let us now substitute all the given. Final pressure is equal to initial volume natin is 12 liters. Huwag ninyong pagpapalitin si initial at si final volume. Ang ating numerator ay 12 liters times 1 atmosphere. Ang ating initial pressure ay 1 atmosphere. Over final volume natin is 4 liters. And then now, let us cancel liters. Then we will just multiply 12 to 1 atmosphere and divide it into 4. 12 atmosphere divided by 4. Final pressure is equal to 3 atmosphere. Sa given pa lang natin kanina, nalalaman na natin kung ano ang kalalabasan ng ating final pressure. At alam naman natin sa Boyle's Law, it is inversely proportional. Kapag si volume ay mataas, mababa si pressure. Sa initial condition natin, 12 liters, mas mataas siya kaysa sa 4 liters. Ang ating pressure ay 1 atmosphere. Mataas si initial volume, mababa si initial pressure. Next, ang final condition natin is mababa si final volume. Definitely si pressure ay mag-i-increase sa 3 atmosphere. At iyan ang solution para sa sample problem natin regarding Boyle's Law. Ngayon, subukan mo naman ang sample problem natin. Pagkatapos kong basahin ng problem, maaari mong i-post ang video at kapag ito ay nasagutan mo na, pwede mo na ulit panoorin para malaman mo kung tama ang iyong sagot. The inflated balloon that slipped from the hand of Trish has a volume of 600 ml at sea level, which is 1 atmosphere, and it reached a height of approximately 8 kilometers where the atmospheric pressure is 0.4 atmosphere. Assume that the temperature is constant. Compute for the final volume of the balloon in liters. Maaari mo nang i-post ang video, learner. Solution. Step 1. Again, write all the given. Our initial volume is 600 ml. Initial pressure is 1 atmosphere. The unknown is the final volume. And then our final pressure is 0.4 atmosphere. Ang ating initial volume ay 600 ml, we have to convert that in liters. Dahil sa problem natin nakalagay dito, compute for the final volume of the balloon in liters. We have to convert first the ml into liters. Pwede din naman after the solution, pwede mo na rin siyang i-convert, pero mas maganda na sa given pa lang, ma-convert na natin. Kasi baka makalimutan mo pa siya later. Madali lang mag-convert, learner. And again, meron akong video para mas maunawaan mo ang conversion. You will just write 600 ml times. Alam naman natin na ang 1 liter ay katumbas ng 1,000 ml. Sa baba natin ilalagay ang 1,000 ml for us to cancel ml. Tira natin si liter since liter naman ang ating desired unit. Cancel ml. Next is 600 times 1. The answer is 600. Copy natin si remaining unit which is liter over 1,000 is equal to, divide lang natin siya, 0.60 liters. Ang initial volume mo na ngayon ay 0.60 liters. We can now move on to the next step, which is the derivation of formula. Again, our formula is initial volume times initial pressure is tantamount to final volume times final pressure. Derive natin siya. Ang kailangan nating ma-eliminate ngayon sa side na ito ay ang final pressure. Dahil ang unknown natin is si final volume. You will just bring down the final pressure. Kung ano ang ibinaba mo sa side na ito, yun din ang ilalagay mo sa other side of the equation. Then it is now time for us to cancel final pressure. Our derived formula is final volume is equal to initial volume times initial pressure over final pressure. Now, let us substitute all the given. Again, write the derived formula for final volume and then substitute all the given. Our initial volume is 0.60 liter. Ito po siya galing. And then, initial pressure is 1 atmosphere over final pressure natin is 0.4 atmosphere. Cancel na natin si atmosphere. Ang desired unit naman natin talaga is liter. Next, 0.60 times 1, there you have 0.60 liters over 0.4. We will just divide. The answer is 1.5 liters. Bumaba si final pressure, definitely ang kanyang final volume ay tataas. Ang initial condition kasi natin, mataas si pressure, mababa si volume. And that is the answer for our second problem. Sana ay nakuha mo ang tamang sagot. Demonstration of Boyle's Law. Nakikita sa picture ang marshmallow at balloon inside the syringe. Same procedure, pulling the plunger of the syringe creates a low pressure inside it. The marshmallow is filled with air. Same with the balloon. Under reduced pressure, the air expands to fill the container, causing the marshmallow and then the balloon to increase its size. Applications of Boyle's Law. First, we have spray paint. Kapag prines mo ang spray paint, magkakaroon ng decrease sa pressure ng gas. Therefore, the volume of the pressurized gas increases. Highly compressed gas expand, and as a result, gas and as well as paint material is forced to get out of the sprayer. Next is the mechanics of human breathing. Mayroon itong dalawang proseso, exhale and inhale. When we inhale, the volume of the lungs increases, which in turn decrease the pressure inside the lungs. As a result, the air rushes inside the lungs. Sa kabilang banda, kapag tayo ay nag-exhale, ang volume ng lungs ay magdi-decrease. Ang pressure naman sa loob ng lungs ay nag-i-increase. With that, air rushes outside the lungs. Another applications of Boyle's Law, bicycle pump, as well as syringe. The volume-temperature relationship in gases was determined by and named after Jacques Charles, 1746 to 1823. Charles' law states that At constant pressure, the volume of a fixed amount of gas is directly proportional to the Kelvin, which is the temperature. Ang dalawang properties ng gases na involved dito sa Charles' Law ay ang volume at temperature. With regards sa temperature, kailangan ito ay naka-Kelvin. If in case ang temperature ay naka-degrees Celsius, kailangan mo siyang i-convert into Kelvin. And it also says here that it is directly proportional. In this situation, an increase in one quantity causes a corresponding increase in the other quantity. In short, kapag mataas si volume, definitely mataas din ang kanyang temperature and vice versa. The graph shows the relationship between the volume and temperature at constant pressure. Tandaan na ang dalawang properties involved in Charles' Law are volume and temperature. Kapag mataas si volume, mataas din si temperature. At pag si volume ay mababa, the temperature also decreases. And that is the Charles' Law. Demonstration of Charles' Law. First, we have boiling water and an inflated balloon on the top of it, and the ice water as well as the inflated balloon. Magkaiba ang kanilang temperatura, mataas na temperatura at mababang temperatura. Magkaiba din ang nangyayari sa inflated balloon. Charles' Law states that the volume is directly proportional to its temperature. Kapag mataas si temperature, mataas din si volume. At kapag mababa si temperature, mababa din si volume. Kung mapapansin ninyo, ang gas particles inside the inflated balloon moves faster. At dahil nga iyan sa mataas na temperatura. While on the ice water, ang molecules ng gas inside the inflated balloon moves closer. Dahil dito, ang inflated balloon sa mababang temperatura ay umimpis or nag-shrink. Mababalik pa ba ang mga balloon na ito sa original size? Yes. Kapag tinanggal mo ang inflated balloon sa boiling water, ganun din ang inflated balloon sa ice water. Babalik siya sa kanyang normal size at room temperature. And that proves the Charles' Law. Application of Charles' Law. Hot air balloon is an application of Charles' Law. Gumagamit dito ng fuel para tumaas ang temperatura sa loob ng balloon. Ang pagtaas kasi ng temperatura ay nakapagpapabilis ng paggalaw ng gas particles. This caused the gas inside the balloon to take up more space. The balloon floats because of its decreased density. Let's have Charles' Law equation. Charles' Law is expressed in this equation. V sub 1 over T sub 1 is equal to V sub 2 over T sub 2, where V sub 1 refers to the initial volume, T sub 1 is the initial temperature, V sub 2 refers to final volume, and T sub 2 signifies the final temperature. Again, lahat ng makikita ninyo na may subscript na 1 refers to the initial condition of the properties of gases. Lahat naman na makikita ninyo na subscript na 2 ay nangangahulugan na final condition ng properties of gases. At yan ang Charles' Law equation. Subukan natin ang sample problem sa Charles' Law. An inflated balloon with a volume of 1 liter at 28 degrees Celsius was placed inside the freezer where the temperature is negative 10 degrees Celsius. Calculate the volume of the balloon if the pressure remains constant. Solution: write all the given. Our initial volume is 1 liter. Our initial temperature is 28 degrees Celsius. Our final temperature is negative 10 degrees Celsius. And the unknown is the final volume. Always remember that for Charles' Law problem, ang temperature ay dapat na naka-Kelvin. Paano i-convert? From degrees Celsius to Kelvin, we will just add 273.15. Our formula in converting degrees Celsius to Kelvin is Kelvin is equal to degrees Celsius plus 273.15. Kelvin is equal to, copy natin yung kailangan nating i-convert, which is 28 degrees Celsius. Ito ang ating initial temperature. 28 degrees Celsius plus 273.15. The answer is 301.15 Kelvin. Ang ating initial temperature ay naka-Kelvin na. Next, kailangan pa rin natin i-convert ang ating final temperature. Again, just write the formula and then substitute the given, which is negative 10 degrees Celsius. Naka-negative ang ating final temperature. Ang rule natin sa math, kapag mag-a-add ng magkaibang sign, you will just subtract it and copy the sign of the larger number. Sa sitwasyon na ito, dahil mas malaki ang 273, isusubtract lang natin siya and then copy the sign of 273, which is positive. The answer is 263.15 Kelvin. Ngayong na-convert na natin ang final temperature, proceed na tayo sa next step. Formula natin, again, initial volume over initial temperature is equal to final volume over final temperature. Dahil nga ang unknown natin ay ang final volume, kailangan nating i-cross multiply. Pagsamahin natin ang dalawang ito. Final volume times initial temperature. Dahil nga ang unknown natin ay ang final volume, kailangan nating i-derive ang formula. We will just cross-multiply this formula. Pagsamahin natin si final volume at initial temperature. Meron na tayo ditong final volume times initial temperature, same with the other side. Initial volume times final temperature. Ayan, napagsama na natin. Initial volume times final temperature. Dahil nga, final volume ang unknown, dito tayo mag-focus muna sa side na ito. Ang goal natin is matira si final volume at ma-eliminate naman si initial temperature. So, ibinaba natin si initial temperature, same with the other side, kung ano ang inilagay natin dito. Ganon din naman ang ilalagay natin sa kabilang side. It is now time for us to cancel initial temperature. Matitira si final volume is tantamount to initial volume times final temperature over initial temperature. Substituting all the given, our initial volume is 1 liter. Ito po yun. Our final temperature is 263.15 Kelvin. This one. Over initial temperature, which is 301.15 Kelvin. Cancel Kelvin. Multiply 1 to 263.15 over 301.15. The answer is 0.87 liters. Charles' law states that volume and temperature is directly proportional to each other. Dito sa ating problem, mataas ang initial temperature natin, which is 301.15 Kelvin, kaysa sa ating final temperature, which is 263.15 Kelvin. Definitely, ang i-expect nating answer sa final volume ay mas mababa. kesa sa 1 liter. Dahil kapag mababa si temperature, mababa din si volume. At pag mataas si volume, mataas din si temperature. And that is the answer for our sample problem. For our next problem, maaari mo itong sagutan pagkatapos kong basahin ang ating word problem. A cylinder with a movable piston contains 230 cubic centimeter at 10 degrees Celsius. If the pressure is kept constant, compute for the temperature if the volume is 130 cubic centimeter. Learner, pwede mo munang i-post ang video na ito at pagkatapos magsagot, maaari mo nang panoorin ulit at malaman kung tama ba ang iyong sagot. Solution. Our given initial volume is equal to 230 cubic centimeter. Our initial temperature is 10 degrees Celsius. Our final volume is 130 cubic centimeter. At ang unknown natin is the final temperature. Again, dahil ang temperature natin ay naka-degrees Celsius, kailangan muna natin itong i-convert into Kelvin. In converting degrees Celsius to Kelvin, remember the formula, Kelvin is equal to degrees Celsius plus 273.15. Kelvin is equal to 10 degrees Celsius plus 273.15. The answer is 283.15 Kelvin. Ngayon, ang ating initial temperature ay naka-Kelvin na. It is now time for us to solve the problem. Our formula, initial volume over initial temperature is equal to final volume over final temperature. I-cross multiply ulit natin. Final volume and initial temperature. Final volume times initial temperature is equal to initial volume times final temperature. Next, let us derive the formula. Since ang unknown natin is final temperature, mag-focus tayo sa side na ito. Again, ang goal natin is to eliminate the initial volume at matira si final temperature bilang ang value naman ng final temperature ang ating hinahanap. Bring down initial volume, cancel initial volume. The derived formula is final temperature is equal to final volume times initial temperature over initial volume. Let us now substitute all the given. Final temperature is equal to 130 cubic centimeter times 283.15 Kelvin over 230 cubic centimeter. Cancel cubic centimeter. Our desired unit is Kelvin because we are computing for temperature. Multiply lang natin ang 130 sa 283.15. The answer is 36,809.5 Kelvin. Copy the initial volume which is 230. Divide lang natin siya. Then the answer is final temperature is tantamount to 160.04 Kelvin. Again, Charles' law. Mataas ang initial volume kesa sa final volume, definitely ang expected nating sagot for our final temperature ay mababa. Sana ay tama ang iyong sagot. Now, kindly get your module and do the learning task. That's all for today, learners. I hope you learned a lot for today's lesson. Enjoy learning because science matters. Good day!